Hey there, IT 140 students. So in this recording, we're going to go through the details of lists in Python. So up to this point, the variables that you've declared and used let you represent one value, and that was it. Now you're going to create a variable that lets it have multiple values associated with it. And we say that it's a list. And what it is again, it's the idea is it's a container that we can put in multiple objects in it. The list is a sequence, and what that means is that they are maintained in a left to right positional ordering. So as I put things into the list, there's an order to them. I know the item, and then I know what's to the side of it. So they're always in an order, and they're in an order based on how we put things in. Lists are created using a bracket notation around the list items. So we've got an example down here. They define a variable called myList. We've got the bracket notation around those items right there. So those items become a list. Oh, by the way, if I don't put any items in there, then it would be an empty list. So if I just go open bracket, close bracket, like we see right here, then we have an empty list. Typically, you're probably going to start with an empty list and then eventually add things to it. Now, Python lets you have lists of any type. Remember, Python is a dynamically typed language. That means you can put whatever you want in any kind of variable. So here we have a string, we have a float, we have an integer value. That's all perfectly legal in Python. Now, oh, by the way, you're probably not going to do this. I can count on one finger how many times I've seen this actually implemented in production code. Keep the lists the same data type, okay? But anyways, continuing on, so we have one variable that lets us reference multiple values here. And then you can see that the idea here is that we have positions. We have 3 positions that are holding values. And in most programming languages, Python included, we start with position 0, the next one is 1, the next one is 2, and so forth. And so position 0 holds hello, position 1 holds negative 4.2, and position 2 holds the value 5. So the index is how we access the items in the list. Again, I just mentioned that it's 0 based, meaning that we start the positions at position 0, and then we can then reference them using the name of the list and the bracket notation. So some common operations that you can do with a list. So here we are declaring our list, easy peasy, just kind of like what we saw above. This makes more sense. We've got some actual integer values that are all the same type. So that's all good. We can also use the list operation here. So we could say list and we give it 1, 2, 3, and it's going to create a list of these separately. These are all strings, 1, 2s, and 3s. There's not much gained here, but you can just do it. Again, to get an element from the list, this could be to do one of two things. This could be getting it for display purposes, or we could be getting it and assigning a value to it. We could specify a start and end to a list. So we might say, give me a new list containing some of another list's elements. A lot of these things like this right here, you're probably not going to use this very much, okay? If you want to join 2 lists, this will take the second list and append it to the end of the first list. And again, this right here, we can add to the end of my list. We'll see a little bit better method for that. It'll be in another section. And then we can delete an element from a list. Again, if we know we're going to remove something, this will delete it from the list. Okay, we go to section 2. So lists have lots of methods available to them. We can add to the list, we can remove from the list, we can sort it, we can reverse it, we can do all sorts of things. So to add an element to the list, the majority of the time you're going to use the append method. So this adds an item to the end of the list. This is the traditional behavior that most people are going to use. We can do the extend operation. This is going to add a list to the end of a list. We may want to insert a value in a specific position. So we're going to insert the value, and this is the, we're going to insert the value x into the position before I. So we're going to put in the value 1.7, and you can see we want to insert it before position 1. So this is position 0. Position 1 is 8, so we're going to put it in before the value 8, which is what this does right here. So when might you do something like this? If you wanted to keep a particular ordering of things. We can remove elements. So the remove method removes a value. So you give it a value, it will remove the first item from the list with that value. So if there were multiple values with that, you'd have to loop through the list, calling that remove method to remove all of them. Again, this just removes the first element of that list. We have a pop method. This returns the last item in the list. So for this list right here, when we call pop, it's going to return back the last item, which is 14. Or we could pop and remove an item at a particular position. So if we say list.pop0, we're going to remove the very first element, and it gets returned back to us. We can use the sort method. So sort will sort the items of our list. So when we call sort on my list, the ordered values are now 5, 8, and 14. Same deal, we could reverse that list. So now we're going to have 8, 5, and 14, just like you see right there. Index, this will give you the index of the first item with a particular value. So if you want to know where in the list is a particular value, we could say, give me the index of 14, and it's going to be 0, 1, 2. It's in the second position. Oh, by the way, the default of this, if it's not in the list, it's going to return a -1, letting us know that that's not a valid index to the list. We can use a count method to count how many times something is in the list. So we can see they're going to say, go count how many 5s are in there, and it returns 3. So lots of built-in methods for a list that you can utilize. So next thing we're going to look at is to loop over a list. So once we have a list defined, programmers typically are going to want to loop through the list. They might be looking for a particular value. If it's a numbers list, if it's like test scores, they might be looping through the list to sum up the values to eventually calculate an average. So the syntax that we can use is a for loop. And so we can say for my variable in the name of your list, your colon, just like a for loop from last chapter, and then whatever statements are going to be executed inside the body of the loop. Remember, these are indented right there. So let's take a look down here. So we have a user input, so they're going to enter in some numbers. So we have a list right here called nums, and then we're going to loop through the tokens that were entered in. So they entered in these values separated by a space. So the split method is going to split it into an array. So we're going to loop through that array, and then we're going to add them to our list one at a time. Down here, we see an example where we're printing each position of our list. And then down here, here's a good example of we're going to check to find a maximum even number. So two things there. We want to determine if it's the maximum, and it has to be even. So we'll loop through our list, and then we're going to check to see if max num, so they're going to assign it to be none to start with. So if it's none and it can be divided by 2, then it is the first even number. Otherwise, we'll continue on. If it's not none and we are bigger than the previous max and we are even, then we become the new maximum value. So this will loop through every item in the list. Again, typically, if we're going to have to find a maximum value, we have to loop through the entire list. If we're going to, again, add these all up to calculate a sum, to eventually calculate an average, we have to loop through all of them. Oh, by the way, when you are looping through a list in Python, if you have 8 elements in your list and you try to access, say, the 10th item, it doesn't exist because you only have 8 elements. This will throw an index error out back to you. So a good way to prevent doing things like this is to always use the for in loop. That way you're guaranteed that you're not going to have an index error. There are several other ways to iterate over a list. There are built-in max, min, and sum methods for a list, so you can utilize those as well. And we move on to the next section. So here in the next section, we're going to talk about the idea of nesting lists. And the idea is we have lists. So I've got a list 513. I have a list containing 50, 70, and 75, and those are within another list. So really the idea here is you have a row containing values 5 and 13. You have another row containing 50, 75, and 100. So it might look like this if I'm thinking about it in a spreadsheet. I have 5 and 13, and then the next row I have 50, 75, and 100. Okay, so what this is it's a grid of rows and column values. So if I reference my list and give it position 0, that's going to be say, give me the first row of values. So here, the first row is 10 and 20. This says give me the next row, which is 30 and 40. And then this bracket notation says, go get me row 0, column 0. And again, I think it's very beneficial to put these into a spreadsheet to visualize this. So I've got 10 and 20. Next row has 30 and 40. So this is position 0, position 1. So that's, I'll do this, row 0. Excuse me, this is column 0, column 1. This is row 0, row 1. So again, very helpful. This is the row column 0, 0. And so row 0, column 0, it's that value right there. If I wanted this value, this is row 1, column 1. So this would be my list 1, 1. So they give an example here. So we've got 3 rows with 2 columns apiece. So we have A and B, C and D, and then we have E and F. So again, I think it's very beneficial to come over here and put it in a spreadsheet so you can visualize it a little bit better. So the idea here is we have a multi-dimensional data structure. Okay, so when we first started with a list, so if I delete out these right here, this is a single dimensional, one-dimensional array. This is a two-dimensional array where I have rows and columns. We could have a three-dimensional array. That would be looking like a cube. You have rows and columns stacked up with a height. So while you see this right here might say, oh, well, this is a 3 by 3, it's still only containing rows and columns. A really good example of the usage of a two-dimensional array is driving distances between cities. So what you have is a lookup table. So let's kind of dump this in here. So we have Boston, Chicago, LA, Boston, Chicago, LA. So the distance from Boston to Boston is 0. Distance from Boston to Chicago is 960, and the distance from Boston to LA is 2,960. From Chicago to Boston, we know is 960. The distance from Chicago to itself is 0, and from Chicago to LA is 2011. LA to Boston is 2,960. LA to Chicago 2011, and LA to LA is 0. So in this lookup table, the diagonals are always going to be 0 because there's no difference between them. But this would be a nice lookup table. If I want to look up the distance from any of these cities to the other, I can just reference it using this two-dimensional array. Another good example is we might have a two-dimensional array containing scores. So this could be the test scores for student 1, the test scores for student 2, and the test scores for student 3. Okay. And then if I need to loop through a two-dimensional array, first thing we're going to do is loop through the rows. So I'm going to loop through this row first. So I would be grabbing this row, 1, 5, and 10, and then I loop through the cells or the columns in that row. So this first time through, I'm going to be getting the value 1. Next time through is 5. Next time through is 10. Then I'm going to shift to the next row, and I'm going to do it all over again. I'm going to start and get the first column value, next column value, next column value, and so forth. So I know the idea of a nested loop is a little bit more tricky for us right now, but hopefully you can kind of just wrap your mind around it as you go through the zyBooks lesson. Now, in section 6.6, they talk about slice notations, where we're going to grab pieces and parts of a list. These are all nice things. I can tell you that I've never, ever once used this in production code. So nice features. I'm going to skip over it. We're not going to really worry about that for our purposes. Section 6.7, though, I do want to emphasize something here, that when you're looping through a list, you can modify the values. You have to keep in mind, to properly do it, though, you have to use bracket notation. So they are looping through a for I loop using the range function, getting the length of the list. So this will go through starting with the first item, going to the last item, and they're going to add 5 to each and every item in the list. Maybe if you wanted to zero these out, you could say instead of plus equals 5, you make it equal 0. So it zeroes them all out. Okay, so this right here is how you would modify a list. Down here, they show an incorrect way to modify a list. So they are using the for in loop. And here, this variable num, you need to consider it as a local variable, only accessible to this loop. It's a read-only copy of the value in the list. So while they set num equal to 0 here, this is only a temporary loop variable. It is not the actual value in the list. Okay, so keep in mind, if you ever want to change the value in a list while you're looping through it, you need to use the bracket notation. And oh, by the way, while you can change the elements in a list, one thing that you want to avoid doing while you loop through a list is adding or removing a list element. So in some programming languages like Java, that is a no can do. You cannot do that. It will throw a concurrent modification exception. In Python, we're going to get unexpected behavior if you're adding or removing from a list as you're looping through it. So if we were potentially looking for a maximum value, and for whatever reason we remove something or add something, we're kind of messing with the algorithm, the intention of what we're doing. So rule of thumb, if you're searching for something, if you're trying to find a max, min, sum, you're not going to be adding or removing anything while you're looping through it anyway. Section 6.8, these list comprehensions. I'm going to skip over all that. And then in 6.9, we've already kind of introduced the idea. There is a sort function. Keep in mind that when you use sort, you have to call it on the name of a list. And so your list, which was unsorted, is now sorted in order. But there is also a built-in sorted function that returns a new list to you. So if I call the sorted function on numbers, sorted numbers is going to be in order. Numbers does not get modified by this. So one thing you always need to pay attention to when you're using methods and functions built in is what do they do? How do they work? You can go just Google sorted function Python and it will explain to you how it works. And so you make sure you're using it properly. Okay, so that's going to do it here for lists. Main ideas here is I want you to understand how to create a list, how to loop through it, how to access the elements in it. Keep it simple. A lot of the extra stuff that's a little bit more advanced, we're not going to be using as we move forward in the class. All right, I'll talk to you next time.